Somewhere off the coast of a desert kingdom, engineers just did something no civilization has ever attempted at this scale. And if you stopped scrolling right now, stay for the next 10 minutes, because by the end of this video, you will understand why the world's biggest banks, the world's biggest engineering firms, and the world's most powerful governments are all betting on a single patch of ocean that used to be nothing but a sleepy fishing village. 4 years ago, this was empty coastline. Today, it is a $200 billion machine rising out of the Red Sea, half of it standing on solid ground, half of it floating on water, and almost none of it makes sense until you see how it was built piece by piece. This is the story of Oxagon, the industrial heart of Saudi Arabia's NEOM Megaproject. And I promise, once you understand what they buried underground before a single building went up, you will never look at a construction site the same way again. Picture the map first. Every ship that moves cargo between Asia and Europe has to pass through this stretch of the Red Sea, a bottleneck busier than almost anywhere else on the planet. And Saudi Arabia looked at that traffic and asked a simple, almost arrogant question. What if we built the first stop those ships ever make? Not a resupply point, not a fuel station. A fully automated port where cranes have no drivers, trucks steer themselves, and the entire operation is run by software watching 7 ships at once on a single screen inside a control room where almost nobody stands. That's where this story begins, but it is not where it ends, because the port is only the entrance to something far stranger. In December of 2021, Crown Prince Mohammed bin Salman unveiled the design for the first time, and it looked less like a city plan and more like something out of a science fiction concept sketch. An 8-sided shape, half rooted in the earth, half drifting on the sea, every angle engineered specifically to break the force of incoming waves before they ever reach the structures inside. Nothing about that geometry was decorative. Every degree of every angle had a purpose, and that obsession with precision is the thread that runs through every single phase of what you're about to see. Before a single crane arrived, before a single truck rolled in, teams of engineers spent months just mapping the seabed, because the ocean floor here is not uniform, it is a patchwork. Coral reef in one spot, soft shifting mud a meter away. And every single meter demanded its own unique engineering solution. You cannot build a floating city on guesswork. So contractors from Belgium and the Netherlands sailed in with heavy dredging equipment. And here is the detail that should stop you cold. Every single cubic meter of material they pulled from the seafloor became the very ground the city's factories now stand on. Nothing was wasted. Nothing was dumped. The ocean literally became the land. But before those dredgers were allowed anywhere near the reef, divers went in first. And by hand, one colony at a time, they physically relocated living coral out of harm's way. Imagine standing on solid ground today, knowing that 3 months earlier, that exact spot was still underwater, still part of the living Red Sea. That is the reality for engineers working this site right now. Once the seabed was cleared and the land began to take shape, the very first thing built was not a building at all, it was a road. Because without that single access route, nothing else could reach the site, no equipment, no materials, no workers. What used to be Saudi Arabia's smallest, quietest port overnight became the busiest construction gateway in the entire kingdom. And here's what almost nobody realizes about megaprojects like this. The parts you never see get built first. Before a single wall rose above the sand, an entire underground city was constructed beneath it. Water lines, power cables, fiber optic data networks, all sealed together inside a single continuous concrete channel and buried before anyone even thought about starting phase 1 of construction above ground. Desert sand, on its own, cannot support the weight of an industrial facility, so every square meter of ground had to be mechanically compacted before a single foundation was poured. Only once all of that invisible infrastructure was locked into place did the real spectacle begin. 4.6 kilometers of seawall built in 24 months, holding back 18 meters of open Red Sea on the other side. Picture that number for a second. 18 meters of ocean pressing against a wall that has to hold, permanently, without failure, forever. To make that possible, steel piles were driven 20 meters straight down into the seafloor, over and over, thousands of them, forming the literal skeleton of the wall. Behind that main wall sit anchor piles you will never see in any photograph. Invisible structures whose entire job is to stop the wall from slowly rotating out into the sea under the relentless pressure of the water. It is deep enough, 18.5 meters at its deepest point, to receive the largest container ships ever built anywhere on Earth. And here is where one mistake could undo years of work. A single capping beam ties every one of those piles together into one unified structure, and engineers on site will tell you plainly, one bad pour, one flawed batch of concrete, and the entire wall could shift. There was no room for error, so they didn't leave any. They used low-carbon steel piling throughout the entire wall, a choice that cost significantly more money but was completely non-negotiable. Because protecting the Red Sea's fragile carbon balance mattered as much to this project as the concrete itself. Meanwhile, out on the water, a dredger sliced continuously into the seabed, while a pipeline carried that material straight to shore, becoming, once again, the very ground the city needed. 4 separate operations were running simultaneously on this one site, 4 different nationalities of workers, all racing against a single 20. 4-month deadline that applied to every one of them equally. And the ocean fought back constantly. Every single week, the Red Sea would quietly refill the dredged channel with its own sediment, undoing progress overnight unless the crews adapted, worked with the tide instead of against it, and eventually cracked the sequencing problem that kept the channel clear. Do you understand how brutal the working conditions were on top of all that? Saudi summer heat regularly hits 45 degrees at noon, so concrete pours were shifted to night shifts that never actually went fully dark, floodlights burning through the small hours so the wall could keep rising on schedule. Those bollards you'll see lining the finished terminal are strong enough to hold ships heavier than the Titanic, and they were cast directly into the capping beam as it was poured, permanent from day one. By November of 2025, the contractor overseeing the wall announced completion. 4.6 kilometers, 7 full berths, finished 2 years ahead of the original schedule. 900 meters of that terminal are now fully automated, capable of processing 1.5 million containers every single year, and requiring 0 human crane operators to do it. This became Saudi Arabia's first completely automated port, and the cranes are not a demonstration. They are already moving real cargo right now, with nobody standing anywhere near them. The entire operation runs out of one control room, and when you stand inside it, you realize the strangest part is the silence. No shouting, no radios, nothing but screens and quiet decisions being made by software. And just as the port phase wound down, a second wave of construction began, this time led by a firm that had previously dredged the foundations for Palm Jumeirah, now here to attempt something even larger. One Saudi company, one Egyptian company, one Chinese company, $1 billion of combined investment, one terminal, one deadline, all converging on the same stretch of coastline. 46,000 square meters of warehouse space is already fully operational, one finished, functioning building standing in the middle of hundreds of others still under construction around it. Since April of 2024, a cargo ship has run weekly between Jeddah and this site, a floating city that, at the time of every single one of those voyages, was still very much under construction. As of November 2025, the project sat at 68% complete, and it is worth pausing on that number, because 4 years before that measurement, this entire stretch of coastline was nothing but empty desert and a small fishing harbor. Once the port structure itself was finished, attention shifted entirely offshore, where a second contractor took over to begin building the actual foundation of the floating section of the city, the part of this story that sounds almost impossible until you see it with your own eyes. Underneath what looks like ordinary factory ground in parts of this site, there is no ground at all. There is only the Red Sea, and an entire section of this city is quite literally floating on top of it. That floating district alone covers an area equivalent to 14 Central Parks, and every single square meter of it sits on open water. Engineers chose a floating design specifically so that marine life could continue living underneath the city without interruption, meaning the coral reef beneath these structures stays alive by deliberate design, not by accident. Reach out and knock on one of the massive concrete pontoons that make up this floating foundation, and it sounds exactly like the hull of a ship, because in every meaningful sense, that's precisely what it is. 50 years of recorded Red Sea storm data went into designing this platform to survive whatever the sea throws at it, decade after decade. Massive anchoring systems hold the entire floating structure in place, engineered so the platform can breathe gently up and down with the swell, but never shift sideways, never drift. The same firm responsible for Palm Jumeirah and Pearl Qatar took on this challenge, and by their own admission, this is the largest floating structure they have ever attempted to build. Stand at the exact point where the solid quay ends, and the floating city stretches out hundreds of meters ahead of you into open water. An entire canal cut straight through the middle so ships can sail directly through the heart of Oxagon. Solid land on one side, floating city on the other. Every single pontoon is pressure tested before it ever touches the sea, because one undetected leak could tilt the entire structure. Imagine a single concrete box weighing 1,000 tons being launched into open water, guided into position by GPS with a tolerance of just 10 millimeters, and then multiply that by hundreds of identical launches, each one as precise as the last. Once in place, post-tension cables stitch. Every pontoon to its neighbors, creating joints so tight under that tension that engineers describe them as essentially unbreakable. Even the water and power cables running beneath the city had to be specially engineered to flex constantly as the platform moves, because anything rigid would have snapped within days of the first real storm. The city even built its own wave break system, so that inside the canals the water sits perfectly calm, while just beyond that barrier, the open Red Sea continues to churn exactly as it always has. place your palm flat against one of these structures, and you can actually feel the platform moving beneath you, gently, deliberately, exactly as designed. To put the scale in perspective, the Prelude FLNG facility once held the record as the largest floating structure on Earth. And by comparison, Oxagon makes it look almost small. Roads, drainage systems, and entire factory foundations are sitting right now on concrete pontoons floating in open ocean, with dedicated canals allowing goods to move from factory floor directly to the port by boat. No trucks required for that final stretch. And behind all of this rises the piece of the story that might matter most for the future of global energy. Just beyond the floating city sits an $8.4 billion facility spread across 300 square kilometers of desert. And it is, without exaggeration, the largest green hydrogen plant that human beings have ever built. 23 separate banks across 3 different continents signed onto financing this single project, making it the largest green energy finance deal ever assembled anywhere in the world. The concept is almost deceptively simple. Sunlight and seawater go in one end, clean burning green fuel comes out the other, with 0 fossil fuels and 0 carbon emissions anywhere in that process. Inside sit electrolyzers built by a major German industrial firm, a 2 gigawatt installation that stands as the single largest deployment of this specific membrane technology anywhere on the planet. The solar farm feeding this entire operation is large enough to measurably change the temperature of the air directly above it, 4 gigawatts of very real, very physical heat radiating off panel surfaces hot enough to burn skin on contact. Within 4 hours, the captured heat and energy is converted into usable hydrogen, an industrial transformation that would have sounded like fantasy a decade ago. Wind turbines dot the site, too, each one taking weeks just to assemble, with individual blades longer than the wing of a jumbo jet. 4 gigawatts of continuous power demanded an entirely new electrical grid of its own, kilometers of fresh transmission lines cutting straight across open desert to keep the whole system fed. Down the line, specialized columns convert that hydrogen into ammonia for transport and storage, quietly ending 150 years of one single fuel source dominating global energy, replaced here by something entirely different. The hydrogen itself gets stored in tanks rated to 700 bars of pressure. Every single weld, x-rayed, every seam pressure tested repeatedly, components manufactured in Europe and shipped across the world to Saudi Arabia without a single scratch on arrival. One critical cooling system inside the plant took 6 months just to construct, a system where 14 different chemicals flow simultaneously through the same set of pipes, and if even one of those chemical mixtures goes wrong, the entire plant has to shut down completely. By June of 2025, the facility sat at 80% complete, on track to become the largest operational green hydrogen plant anywhere in the world. A major American industrial gas company committed to purchasing every single ton of output for the next 30 years, and they signed that agreement before the plant itself was even half finished. Once complete, this single facility is projected to produce 600 tons of hydrogen daily, translating to 1.2 million tons of ammonia every year, all shipped out from one specific berth built for exactly that purpose. The projected environmental impact is staggering on its own. 5 million tons of carbon dioxide avoided annually, a figure larger than the total annual emissions of some entire countries. Nobody on Earth had ever operated electrolyzers at this scale before, meaning the control software running the entire plant had to be built completely from scratch, with no existing blueprint to follow. Every one of those electrolyzers requires ultra-pure water to function, which meant engineers had to construct an entire dedicated desalination plant just to keep them fed. First ammonia production is targeted for 2027, though 2 more years of commissioning and testing still stand between now and that milestone. For 100 years, Saudi Arabia's global identity was built entirely on selling oil, and this single port is quietly beginning to sell whatever comes after it. Delegations from Japan have already visited multiple times, each one trying to determine whether green hydrogen can actually work as a viable, large-scale commercial business, not just an ambitious engineering exercise. Massive industrial compressors squeeze the finished hydrogen up to that 700-bar storage. Pressure, each individual compressor unit costing tens of millions of dollars on its own. When clouds pass overhead and block the sun even briefly, the electrolyzers automatically adjust their output within seconds. No human intervention required at any point. And just when you think you understand the full scope of what's being built here, there's a twist almost nobody saw coming. In February of 2025, Oxagon quietly announced a $5 billion artificial intelligence data center campus, and virtually no analyst covering the project had predicted it. The site offers 3 things almost impossible to find together anywhere else in the region: abundant power, ready cooling water, and vast open land, and Oxagon happens to have all 3 in the same place. This is being built as the world's first net zero AI data center campus. $5 billion of computing power cooled directly using Red Sea seawater, with every discharge point monitored hourly to protect the reef beneath it. The hydrogen plant, sitting just down the coast, will actually help power these very same data centers, tying the entire site together into one interconnected energy loop. $12.8 billion total is now committed to AI infrastructure at this location. And this is not a server room in the traditional sense. This campus is being built specifically to train some of the largest artificial intelligence models on the planet. More than 4,000 factories across Saudi Arabia are expected to eventually connect directly into the computing infrastructure being built here, making this campus something close to the nation's digital brain. Not every announcement tied to this site has moved as fast as promised, however, and it's worth being honest about that. A $10 billion logistics partnership announced with considerable fanfare is still not operational as of 2026, a reminder that megaprojects of this size rarely move in a straight line. But beyond the port, beyond the hydrogen, beyond the AI campus, there's one part of this story that changes everything. Because 90,000 human beings are expected to actually live here by 2030, with industrial zones continuing to rise around their homes, even as they move in. In an almost poetic twist, the very first structure completed on site was housing for the 20,000 workers who are building everything else, a village built to house the people constructing the rest of the village. As early as May of 2024, families were already moving into finished apartment units, while cranes, visible from their own windows, continued building the next block over. Every single apartment in this residential district faces directly toward the Red Sea, and the building facades are specifically engineered to block 60% of incoming heat during summers that regularly exceed 45 degrees. There are no private cars permitted anywhere inside the residential zone, only autonomous vehicles, a decision that has already reduced delivery times inside the community by 20% in its very first year of operation. Every tap in every home runs on desalinated Red Sea water, drawn from the exact same treatment plant that also feeds the hydrogen facility down the coast, one shared system serving completely different purposes. Nothing here is designed to become landfill waste. Every material used across the entire site is contractually required to loop back into the system rather than simply being discarded. The community's school opened its doors before the surrounding city was even finished, meaning families began their new lives here while construction walls were still visibly rising around them. Engineers even built a dedicated marine research laboratory on site, specifically to study the very reef ecosystem their own construction work has had, to carefully route around at every stage. A cruise terminal now sits alongside everything else, meaning this single stretch of coastline simultaneously functions as an industrial port, a green hydrogen refinery, an AI training campus, and a cruise ship destination, all within walking distance of each other. As of April 2026, the entire project sits at 55% complete, meaning nearly half of this staggering vision still remains to be built, and by every account from the engineers actually working here, the hardest phase is still ahead of them, not behind. Having now walked you through nearly every major system on this site, from a wall built to hold back 18 meters of open ocean, to a floating district the size of 14 city parks, to a hydrogen plant unlike anything else on the planet, to an AI campus meant to think for an entire nation's industry, it becomes hard to describe this place using any single familiar category, because it genuinely does not fit into one. If this breakdown gave you a real sense of the scale of what's happening in the Red Sea right now, make sure you're subscribed, because projects of this size rarely stay the same for long, and the next update from this coastline is going to be worth watching closely.